Good morning, everyone. My name is Wiwi. Today I'm going to talk about effects of ocean acidification on the larvae of a high-value pelagic fisheries species, Coryphena hippulus. First, I want to show you today's main character, Coryphena hippulus. And it is also called Mahi, Dorado, or dolphin fish. And I prefer dolphin fish much more. And the dolphin fish can grow up as 2 meters and over 30 kilograms. Next. And the dolphin fish is carnivorous, so it feeds on flying fish or the squid. And it is one of the fattest growing fish in the world. And it is said that it only takes 1 year to grow up from the larvae to the adult. And the dolphin fish likes to live in tropical to subtropical water, and it's warm water. So we can also see them in the northern of Taiwan, such as Taitung or Hualien, or even in the fish market. And how about its larvae? And every female adult spawns 2 times every year, spring and autumn respectively. And the larvae got sexually mature in 4 months. Next, let's move on to our research background. And I want to introduce what is ocean acidification. And it's that when the carbon dioxide is absorbed by the seawater here, and it will generate into a carbonate acid. And the carbonate acid will dissociate into the bicarbonate ions and the hydrogen ions. And we all know that more and more hydrogen ions will lead to the seawater pH decrease, and it will make the seawater more acid. Next, the hydrogen ions will look for carbonate ions to generate into other bicarbonate ions. So the concentrations of the carbonate ions decrease too. Next, and it is the calcification equation. And when these decrease, the directions of these reactions becomes left to the right. So we can know that the saturations of calcium carbonate decrease too. And this may be a serious problem for some marine organisms, like shells, shrimp, or crab, or even the pteropods or the foraminifera. Our motivations to do this research is that we want to know the impacts of ocean acidifications on the marine organism. And for why we're choosing pelagic fisheries is that we want to know more and more research focus on calcifying invertebrates and reef-associated species, not pelagic fisheries. So we choose Mahi for our research. Next, what we want to know from the larvae. 1. We want to know where ocean acidification affects larvae's hatch rate. 2. We want to know where elevated carbon dioxide affects larvae's body length. 3. We want to know where ocean acidification affects larvae's flexions. And what is flexions? And the flexions is important part of the fish's life stage. And here is his life stage, and here is the flexion part. If they cannot undergo this stage, they cannot grow up and will die basically. Next, we want to know, does larvae's otoliths be affected by ocean acidifications? And what is otolith? It is also called earstone, and it is composed of calcium carbonate. And in this research, we want to analyze the lepidus and the sagittal part. And what is that? Sagittal part is about the sun, and the lepidus part is about their body balance. Next, let's move on to our preparation. And in this research, we designed 3 experiments to do some analysis. And in every experiment, we use ambient seawater as a control group. And we simulate the conditions of the future. For example, the experiment 1 and 2 are designed to simulate over the next 75 to 150 years. While experiment 3 is to simulate the next 2 centuries. And next, larval rearing. First, we coat 2 females and 1 male to spawn eggs. And next, we put the eggs into the fiberglass tank, and we cover with shade cloths and lids to prevent light, carbon dioxide, and the rain penetration. Third is about the larva feeding. And all the larva feeding is under green water rearing technique. And what is that? What is green water? And green water is that composed of abundant phytoplankton or microalgae. And it has lots of vitamins, carotenes, and proteins. And the green water can provide a direct food source for the fish larvae. So overall, the green water is good for the fish larvae. Finally, let's get the result. Part 1 is about their hatch rate. From this chart, we can see the x-axis is the partial pressures of carbon dioxide, and the y-axis is their hatch proportions. And please notice that the darker color bar of the chart means the higher treatment of carbon dioxide, while the lighter bar is the lower carbon dioxide. And from this chart, you can see that the proportion slightly decline, but the changes between each other are not significant. And the second part is about their body length. And the x-axis is day post hatch, also called DPH. And the y-axis is the standard length. And let's take a first look at the left part. And we can see that the standard length increased at 5 to 8 day post hatch. But the changes between each other return to not significant after 9 day post hatch on the elevated carbon dioxide. The third part is about their flexions. And the x-axis is the same as the previous one. And the y-axis is about the proportions of undergoing flexions. And from this chart, we can notice that as time went on, more and more larvae underwent flexions. And the changes among each other seems not significant. Next, the final part is about their otoliths. We can see all the x-axis is about Sapida and the Lepidus, while the y-axis is about otolith length, width, and the area. And from these 3 charts, we can obviously see that the data all is significant and the otolith size become larger in every experiment. You can see here, here, and here. In the end, here comes the conclusion. Sorry, it seems like I speak so quickly again. Okay. So I have to slow down the speed. Okay. In the end, here comes the conclusion. Number 1, will ocean acidification affect larvae's hatch rate? No. Number 2, will elevated carbon dioxide affect larvae's body length? No. Will ocean acidification affect larvae's flexions? Also no. So we can know that the larvae were not particularly sensitive to ocean acidification, because we did not find any significant change in their hatch rate, size, or flexions. Number 4, does larvae's otolith be affected by ocean acidifications? Yes. Because in present study, we found an increase in otolith size, which may impact the larvae's listening sensitivity and the hearing range. Most important of all, this study did not put several important factors, such as more detailed impacts of acidifications and the factors of climate change. So we cannot prove that larvae are immune to the impact of ocean acidification. Thanks.
OK。